Welcome to the seventh lecture of this course on mechanical and electrical systems of mining machines. So, we are continuing in module 1 where we will be learning about toothed gears. So, when we talk about toothed gears, we will first talk about what are toothed gears, and then we'll talk about the classification of the toothed gears, then gear terminologies, we'll go to gear terminologies, then gear materials. We'll then derive the length of path of contact, and finally we'll understand what is contact ratio. Now coming to what is toothed gears? Well, we understood in last class about belt drives. So there we understand that there are two pulleys and then there is a belt which passes over it, which transmits power from one pulley to the other pulley. One is a driver pulley, another is a driven pulley. Let's say the space between the two pulleys is very less, and how we would then transmit power from one to the other. So if we go with the same configuration, there will be a high chance that in some time after the belt is used, there will be a problem of slippage. We understood what is a problem of slippage in last class, and we also understood how to get the final driven speed while there are two pulleys and the belt which passes over it slips from over one of the pulley. So now in some devices, let's say like your watch, in watch, if let's say there is this kind of slippage that occurs, then it would create a bigger disaster. Like, well, you have to reach somewhere at 4 p.m., you will reach there at 5 p.m. or you may reach early as well, depending on where the slippage has happened. In order to avoid such conditions, we use another mechanism for power transmission, that we can make it happen through the toothed gears. Now let us understand what is this toothed gears. So let's say there are two friction wheels. One friction wheel is the friction wheel A, and then there is another friction wheel which is P. Now you see, when we bring these two friction wheels closer to each other, they will be able to transmit power until and unless they have sufficient amount of friction between them. That is, the surface have sufficient roughness, and when they are brought closer to each other, so there is some coefficient of friction. However, while you use it over a period of time, so it may happen that these wheels would lose its frictional properties. So in that case, there will be a slippage of these friction wheels. So in order to avoid this friction, what we do is we replace the outer periphery of these friction wheels with teeths. So something like this. So now you can see there are two wheels here which is able to transmit power because they have sufficient friction between them. However, if we replace this circumference of this wheel with something like this, where they have protruded teeth which are meshed with each other and helps in power transmission, so this actually helps us in achieving positive drive. There will not be any slippage between the two friction wheels, and even over the time there will not be any loss of the friction, as we can see in case of the friction wheels without teeths. So this kind of friction wheels where it has teeth cut on the periphery, we call them as toothed wheels or toothed gears. Now, how do we classify these toothed wheels? So we classify them according to the position of the axis of their shaft. So now if you see here, these are the two wheels. This is one wheel, this is another wheel. One we call as the driver, the other we call as a follower. And at the pith circle, you can see the mating happens between these two wheels at the pith circle. Now this teeth rises from somewhere inside this speed circle, which we call it as the base circle, and then it meshes with the teeth of the other wheel. Now when the shaft, they are parallel to each other and the gears are meshed in this configuration, we call them spur gear. This is a two parallel and coplanar shaft. So if you see these two shafts, they are in one plane. Here you can see the driver is rotating in clockwise direction and the follower is rotating in anti-clockwise direction, which we call it as the driven gear or the follower. Again, now this spur gears may have inclined teeth. Here you can see they have straight teeth. However, they may have inclined teeth, so that we call it as the helical gears. Again, they are classified under parallel and coplanar shafts. Well, there can be another configuration which we call it as the double helical gears, or we also call it as herringbone gear. This herringbone gear is similar to the bone of a fish. So these are the other configurations that you can see here of helical gears and double helical gears. Now coming to the second type on the position of the axis of the shaft, that is intersecting. When the two shafts, they are not parallel and they are intersecting, then we call them as bevel gears. So you can see in the bevel gears also they have straight teeth, inclined teeth and curved teeth. Okay, so these are again the classification of this tooth wheels based on the shape of their teeth. Now the third category in this position of the shaft is the non-intersecting and non-parallel gears. So what do we understand? That when the shaft, both the shaft, that is from the driven and the driver, they are not parallel, they are something like this, and then they are also not intersecting, because this shaft will never intersect with this shaft. So that we call it as non-parallel and non-intersecting gears, which we also call it as a spiral gears or skew bevel gears. Now according to the peripheral velocity of the gears are divided into three categories, that is low velocity, medium velocity and high velocity. In low velocity, the velocity is less than 3 meters per second, and in medium velocity it is the velocity of the gears would be between 3 meters per second to 15 meters per second, and the gears velocity, if it is more than 15 meters per second, we call them as a high velocity gears. Now according to the type of gearings as well, the tooth gears are divided into three categories. One is the external gearing, as we have seen in this case where the gears are on the outer surface of the wheels. There can be internal gearing where the teeth are in the inner surface of the wheels, and then there is one pinion which is rotating on it, and there is a third category which we call it as a rack and pinion. So in rack and pinion, you can see there is a pinion which has a rotatory motion, and then there is a rack which has the translationary motion. So this kind of configuration helps us in converting the rotary motion into translatory motion or vice versa. Now according to the position of the teeth on the gear surface, as I have already discussed, they are of three types, that is straight, inclined or curved. So here you can see the straight teeth, here you can see the inclined teeth, and here you can see the curved teeth. Now what are the advantages and disadvantages of the gear drives? Let us first go to advantages. So it helps us in transmission of exact velocity ratio, because there is very minimal chance of slippage until and unless the teeth of the gear breaks or there may be some kind of vibrational disadvantage, there won't be any loss of the velocity ratio. It may be used to transmit large power, which is not possible, which may not be possible in other configurations where there is a possibility of slippage. It has high efficiency, it has reliable service, and has compact layout. When there is a compact layout, so in belt drive there is a possibility of slippage. However, that is the advantage of a gear drive. When there is a compact layout, it gives us 100% positive drive. Now, what are the disadvantages? Is the manufacturing of gears requires special tools and equipments. It cannot be just made by any of the worker. So there is a process called hobbing. So in using that process, the gears are made. Now the error in cutting teeth may cause vibration and noise during operation. So if the gears are not properly made, so then there may be vibration and noise that may be transmitted, or that may lead to the breakage of the teeth when they are in mesh with each other. Now coming to certain terminologies that are used in gears. So now the first is the pitch circle. Well, we understand that when there is a gear, the circle which matches with the circle of the outer circle of the other wheel, we call that as a pitch circle. Now when these two circles are meeting with each other, they would meet at a single point, which we call it as a pitch point. Now the second terminology is the pitch circle diameter. Well, when there are two wheels and the circle, the imaginary circle which helps in meshing of the two gears, we call that as a pitch circle, and the diameter of that circle, we call it as a pitch circle diameter. And the point where these two wheels mesh with each other or met with each other, we call it as a pitch point. Now when we are talking about the pitch circle diameter or a pitch point, we are considering a cross section of this gear. However, the gear is not a 2D element, however it is a 3D object. So while we are talking about a 3D object, so instead of a point, there will be a surface which should be meeting with each other. So when we talk about this surface, we call it as the pitch surface. This pitch surface is the surface on the pitch circle which is generated when the two wheels are in mesh with each other. Now coming to the fifth term, that is the pressure angle or the angle of obliquity. Now we understand that when there are two wheels, they will be meshing with each other, and there will be a point at which they are meshing with each other. Well, if we draw a tangent to both of these two circles and the tangent to the base circles of these two gears, well, let me draw it. Let's say this is the imaginary circle. These two gears are meshing. So let's say this is wheel 1, this is wheel 2. Now there will be a base circle of these two wheels. Now again there will be two circles which we call it as the addendum circle. So these two are this one and this one, we call it as the addendum circle, and this one and this one, we call it as a base circle. As you can see here, this is the base circle, this is the pitch circle, and this and this are the addendum circles. Now when we draw a tangent to both of this pitch circle. Let's say we draw a tangent to the pitch circle and we draw a tangent from the base of one wheel to the base of another wheel. So, this angle that is formed, we call it as a pressure angle or the angle of obliquity. So, generally this angle varies from 14.5 degree to 20 degree. So, you can also see here there is this line which is the tangent to both of these base circles. So, this angle here is the angle of obliquity. Now, the sixth term is addendum. Now, the radial distance of this addendum circle, that is the top circle or outermost circle which passes through the top of the tooth, we call this radial distance, we call it as the addendum. Again, when we take the radial distance from this pitch circle to the base circle or the inner circle, we call this as dedendum. Now, the outermost circle is called as the addendum circle, the innermost circle is called as the dedendum circle. So, now when we talk about this root circle diameter, that is the dedendum circle, is cos phi times of the pitch circle diameter. So, we will understand how this relation goes when we are deriving the length of the path of the contact. So, one thing we must understand, you can see there are two wheels. One wheel is this is one wheel, this is the other wheel. Now, one wheel teeth is getting meshed with the teeth of the other wheels. So, what we can see here is when this tooth is meshing with the other wheel tooth, so they are moving in one line, and you can see they are moving on the tangent line that is drawn to the base circle of this two wheels. Now, you can see it is not exactly starting from this point to this point. They are starting somewhere here and it is getting disengaged somewhere here. So, it is not the complete tangent length, however, it is a part of it. Now, coming to the 10th term, that is the circular pitch diameter. So, what do we understand by circular pitch diameter? So, it is the distance on the pitch circle from point of one tooth to the distance, the same point on the other tooth. So, how do we get it? Let us say we have n number of teeth and we know what is the circumference of this pitch circle, that is pi d. So, if we have to find this distance of the circular pitch, it is pi d by t. However, when we see that there are two wheels which are meshed with each other, their circular pitch should be same with to each other, that is pi d1 by t1 is equal to pi d2 by t2. So, this gives us a relation between the diameter and the teeth of the two gears. Now, coming to the diametral pitch. So, the diametral pitch is the ratio of the teeth to the pitch circle diameter, which is given by d by t, and it can also be written as pi by circular pitch, which is PC. Well, coming to the 12th term, that is the module that I was mentioning earlier, that if the module of the two gears are not same, then they cannot be meshed with each other. So, the ratio of the pitch circle diameter to the number of teeth denotes the module, and the module of one gear should be equal to the module of the other gear, which is denoted by our circular pitch, which is d1 by t1 is equal to d2 by t2. Now when we talk about the clearance, so what do we understand here is, let's say there is one tooth, another tooth which is in mesh with this tooth of the first wheel. So the complete topmost part of this gear is not in mesh or doesn't matches the base circle diameter. So this distance, the radial distance between the addendum circle of the other gear to the dedendum circle of the first gear is called as the clearance. Now what do we understand by total depth? So the total depth is the dedendum plus addendum, that is the radial distance of the base circle to the pitch circle plus the distance, the radial distance from the pitch circle to the addendum circle. Well, when we talk about working depth, it is the total depth minus clearance. Now coming to the tooth thickness. So when we talk about the tooth thickness, this is the point on the pitch circle of one tooth to the point on the pitch circle on the same tooth where the tooth starts and ends. So this we call it as the tooth thickness. Now what do we call as tooth space? So the point where one tooth ends to the point on the pitch circle where the other tooth starts, we call that as the tooth space. Now what is backlash? Well, when we talk about this radial distance along the pitch circle, we call it as a clearance. However, there can also be gap in between the side walls of one gear to the side walls of the tooth on the another gear on the pitch circle. We call it as a backlash. Now what is the face of the tooth? So well, when we talk about the surface of this tooth above the pitch circle, we call it as the face of the tooth. So this line is the pitch surface element. Now the surface of the tooth below the pitch surface element, we call it as the flank of the tooth. Now when we see the top part of a gear, it looks something like this, which we call it as the top landing. Now the width of this top landing, we call it as the face width. So this is the face width. Now what do we call as the profile? So this outer curvature of this tooth, we call it as the profile of the tooth, and this radius that it makes at the base circle, the profile of the tooth make at the base circle, we call it as the fillet radius. Now coming to path of contact and length of path of contact and arc of contact. So let me make you understand by a drawing. So now these are the two gears which are in mesh with each other at the pitch circle. Now here there is a base circle to both the gears. Now there is a addendum circle also. To both the gears. Now this is the point where they are meshing. But what is the point? Let us take the center of this pitch circle. So this is one center O1, this is another center O2. Now from where do they start meshing? Now let us see for this circle. Now first of all, let us draw a tangent to the base of the circle. So we understand that from through on this tangent only the length of the path of the contact would start. But where exactly is the point? It is the point on this line where your addendum circle of the other wheel intersects. So this is the point which we call it as, let us denote it as K. So this is the point where the two gears starts meshing. And where does it ends? This is at the point which is on the addendum circle of this wheel, which we denote it as L. So this complete length we call it as the KL is the path of contact, and this is the length of the path of contact. Now when we talk about the arc of contact, let us say from this point, this is let's say this is point P. From this K we draw a perpendicular, we draw the locus of this point on the pitch circle. So this arc, that is, let us denote it as G. So this we call it as the arc of contact. The same way here also, when we draw perpendicular from this side, we call it as the arc of contact for the path of recess. Now what is this path of approach and path of recess? So now the point of engagement, that is here the KP, is called as the path of approach where the engaging starts, and from P to L it is called as the path of recess where the disengaging of the gear starts. So that is why KP is called as the path of approach and PL is called as the path of recess, and GP is called as the arc of path of approach and PH is called as the arc of path of recess. So that's all in this lecture. In next class we will start with the length of the path of contact. Thank you.